All right, hello, greetings everyone, and welcome to my channel. I am Professor L, and this is a session of Ask Professor L, live interactive. So if you have math questions that you would like to see answered in real time, don't hesitate to put them in the chat. And in the meantime, I'm going to be presenting how to graph a tangent function. So at the very end of the session yesterday, I ended with the graph, a really poor sketch of the tangent function. And so I also realized that I didn't talk about the period of the tangent function or the domain and range. So I'm going to go ahead and backtrack and actually spend most of this session graphing a much more detailed graph of the tangent function and talk a little bit more about some other values and what makes the tangent function so much different than sine and cosine. It's grouped together with sine and cosine, and it is a trigonomeric function. However, it's behaves more like a rational function with these partitions that we talked about a little bit yesterday, asymptotes. So asymptotes are kind of a important topic when you're talking about certain graphs and the graphs behaviors of the graphs of rational functions. So I realized that I didn't really talk too much about what an asymptote is, so I want to kind of clarify. Asymptotes are vertical lines and horizontal. They could be horizontal as well, but for this intent, for this purpose, tangent is they're vertical asymptotes in this case, and vertical asymptotes are found when your denominator goes to 0 of your function. So anytime you have a rational function, what I mean by that is it's a function involving a fraction of some sort that you end up with x in the numerator, and or you have a variable in both the numerator and the denominator, then you'll have potential areas in the graph where you learn early in elementary school that for some odd reason you just can't divide by 0. And then if you carry your math knowledge and your math understanding so far, that you'll find out that you can divide by 0, weird things happen. So, but for now, we just want to know that when you attempt to divide by 0, you get an undefined value, and basically you get this partition in the graph. So what I'm going to do is I am going to try to relax and get settled into my board because it's probably going to be a daunting task what I'm about to do. So I am going to graph the tangent function. So go ahead and change my title too. And I'm going to only use, rather than pulling all those values from the unit circle, I'll just use the brute force method. So I want to title this one Graphing Tangent. So we have this, we have y equals tangent x, or tangent theta. But in this case, we can use x and talk more about the period. So the sine and cosine function have a period of 2 pi. So whenever I graphed the sine and cosine function, I graphed it. Oh, I'm not going to talk about negative angles yet, so we'll go ahead and take off that. I won't get too ahead of myself. We'll leave it here. Anyway, We talked about, we started at 0 here, and we went out to 2 pi for sine and cosine. And the reason why I did that was because I wanted to sketch one complete cycle of the graph. They're called periods. One complete cycle of the graph where you end up, we started here at 0 at the origin, and we ended up back at 2 pi. It was 0 again. One of the main differences in the tangent function, what separates tangent from sine and cosine, is the fact that it has a different period. So the period for tangent goes through pi, so 0 to pi. And so what we're going to do is we're going to go ahead and go out to pi here from 0. Okay. And then we're going to have a lot more values, because since tangent is so much different, we're actually going to use both of those triangles. So those special triangles that I've been talking so much about, you've got your, so that would be the radical 3, 2, 1. So this would be your 30, 60. And then we need the 45. So I'll just draw them here. Let's see if I can get them. I can already tell my math is improving, even just doing this for a week. Because that first week was a little rough, and I was having to redraw triangles and stuff, and I will continue probably to get better at it if I keep this up. This is really good for me. So 1 to 1, radical 2. So what we're going to do is we're going to use the brute force method, and we're going to construct all of the values that we need for the as many points as we possibly can for tangent. And so I'm going to go ahead and put, where do I want to put my table? My table up here. So this is going to be my domain and my range, my input and my output. And remember the trigonometric functions, the 3 main trigonometric functions, they will take an angle into their domain and produce a ratio, a number. And for sine and cosine, remember those numbers are between 1 and -1. And then for tangent, they're a little bit different. But the game is still the same. You're still taking an angle and into this function and evaluating it. So we've got 0. And then we need this. We need one more thing. I'm just going to draw it up here. Tangent, and this is the basic quadrant system. So at 0 and 2 pi out here, we're going to go ahead and list those values of the unit circle. This was when cosine was 1 and sine was 0. And then this one was when cosine was 0, sine was 1. Out here is -1, comma 0. And down here was 0, comma -1. And then I'll also list the quadrants. 1, 2, 3, and 4. Remember, they're both positive here. Well, I already have that here, so we'll just leave it. This is good enough, having those values. So this is going to help me to calculate when tangent, recall tangent, tangent of theta, and I prove this, equals sine theta over cosine theta. And remember, theta just represents an angle. So this ends up being that ratio y over x. So what I'm doing is I'm taking y over x to produce these values. So I'll start out with 0, and I don't need 2 pi. I'm just going to pi. So really, I can cut out the bottom quadrants. I just need the top 2. So at 0 degrees, I have 0 divided by 1. So we're on list my calculations. Okay, for 0 degrees, so y over x is 0 over 1, which is 0. Because you can divide by 0, 0 by a number, but you can't divide a number by 0. So that's just going to produce 0. And then we're going to go to, let's see, how am I going to split this up? We're going to split this up, figuring out, all right. I want, okay. So on that first quadrant of the unit circle, I guess I'll have to use a little bit. So we're going to need quadrant 1 just for a moment. So I've got the 45. So this is that 1 and 1. And you have the unit circle, and you have that pi over 4, right? Well, we also have pi over 3, and then I think 30 degrees was pi over 6. And so that's how we're going to partition it. So until we get to pi over 2, we'll have, so what I want to do is I want to list all of my inputs first, because that's the way the independent variable works. X is always independent. Y depends on whatever X is. So the game in graphing any function, even if it's the most simple or the most complex, is you pick values for your independent variable, and then you plug in and figure out what your dependent is. So we have 0, and then we're going to go up to pi over 6. And then we're going to do pi over 4. And then we're going to do pi over 3. And then we'll do pi over 2. And then that'll put me up to this point, pi over 2. And then I have to remember those values. What is the fastest way to find? Okay, so I'll have to do that again because I erased it. So I've got pi over 2 plus pi over 3. We gotta go back. Remember, I said I was doing this the old-fashioned method, or no, the exhaustive method is what I said. And it's okay because I'm just practicing working on my board and talking and trying to explain the best I can. Right. So when you're adding fractions, get a common denominator. 2 goes into, see, 6 3 times. So we have 3 pi. And then 3 goes into 6 2 times. That's 2 pi. So that's going to give me 5 pi over 6. And that's going to be my 60 in quadrant 2. So I think the next value is going to be 5 pi over 6. And then we're going to add pi over 2 to pi over 4. This one already has a common denominator of 4. So 2 goes into 4 2 times. So you got 2 pi plus 1 more pi, and that's going to give me 3 pi over 4. So that'll be my next 3 pi over 4. And then one more, we've got pi over 6. So we're going to add pi over 2 plus pi over 6. I noticed that my marker's not squeaking today. That's good. So 2 goes into 6 3 times. So we got 3 pi plus 1 more pi. is going to give me 4 pi over 6. What did I do wrong? Did I do something wrong? Maybe. All right, so 4, half of 4 is 2. I guess not. All right, and then half of 6 is 3. 2 pi over 3, does that sound right? We have the unit circle anywhere handy. Oh, it's bothering me that I don't have it memorized yet. So I have to double check my values and make sure I didn't do bad math. That's one of the reasons why some people don't like math and they're discouraged, is because like one moment you could be complete understanding and the very next moment you're like, oh, I'm lost. And that's good for anyone, even someone like me that's been studying it for many, many years. So what do we have? We got 5 pi over 6, 2 pi over 3, 3 pi over 4, and 5 pi over 6. I just have them backwards. All right, so I have to switch these around, of course. All right, so we got 5 pi over 6, 3 pi over 4. Hang on. All right, 2 pi over 3, was it 3 pi over 4, and 5 pi over 6. All right, I think I got all the points successfully. And then where is that unit circle? And now the microphone in this room, it's so weird because one of the last things that I was struggling with to get this live stream up and going was the microphone. And now it's like, it's just a cheap webcam, and it's amazing because the microphone works too well now. All right, so we got 2 pi over 3, 3 pi over 4, and 5 pi over 6. Perfect. All right, and then we should have pi in here. So we got to get pi. So pi is in there too, because the period of the tangent function is 0 through pi. So we'll make sure we get one full complete period. And I'm almost there. So I've got all my angles. And that was the easy part. The hard part is actually figuring out, it's not completely difficult. I mean, this is still pretty good, easy math, but it's more difficult than getting the angles, I think. All right. So once you have all of your domain figured, or not the domain, but the values in your domain that you're going to sketch, then you'll go ahead and partition your graph. And then if you didn't know the perfect partitions, you could use the midpoint formula to figure that out. But halfway between 0 and pi is pi over 2. So try to see if I can get that right there in the halfway point. Pi over 2 might live right in there. And then halfway between pi over 2 and 0 is pi over 4. And I found that this is the easiest way to partition the graph. It does take practice. But pi over 2 and pi is going to be 3 pi over 4. And, it might be useful to go off on a tangent and just show the midpoint formula once, but I'm afraid that I might, that might be a little too much for what I'm trying to do. I gotta stay focused. So we've right in here. I've already got them laid out, so I'll show you all the midpoint formula some other time when it's more convenient. All right, so that looks like it's about half, and then we'll go ahead and put these other values in. Halfway between, well, it's not halfway between, it's a little bit less than half. It's 15 degrees difference between these two values. Okay, but we're still going to go ahead and so we'll put, and we're just guessing pi over 6 is probably in here. And then we got, wait a second. This is mixed up because, wait, pi over 6. So that's, no, that's right, pi over 4. And then 60 degrees. Okay. That's all right. So it'll be right in here. Pi over 3. Ah, I haven't done this in a while, but it's okay. It's good for me. All right. So then we have 2 pi over 3. And then we've got one more value to plug in here. We've got 5 pi over 6. Pi over 6. And I'm really hoping that that's not that's not too blurry. I'm hoping that I'm not writing too small for the camera. All right, so we've got that. Now what we have to do is we have to figure out what y is doing. Okay, what the function is actually doing, the behavior. In order to find the behavior of the function, you have to take these values and you're plugging in for x. So what you're doing essentially, like yesterday, I just used the unit circle to go ahead and find them real quick. But what you're actually doing is you're taking this function y equals tangent and plugging in for x 0. And then remembering, well, when tangent is 0, anytime sine over cosine is 0. And so it's going to be at these, it'll be, so this one is y over x. So what you're doing is you're saying 0 divided by 1, and that's 0. So tangent of 0 is 0, and then you plug in here. And then you repeat that process for y equals tangent of your next value. And then you take pi over 6, and you plug pi over 6 in to tangent and see what's going on. Well, pi over 6, if you recall, is 30 degrees. So in order to calculate the tangent, you use your special triangle, 30 degrees. And tangent is, by definition, it's opposite over adjacent. So maybe I need to put that in there somewhere. Here, we'll put it up here. Right here. No, I don't want to mess up my graph. So we'll just say tan theta is op over adjacent. Okay, so when you're doing your special triangles, you're looking for opposite 30 degrees, which is 1, and adjacent to 30 degrees would be radical 2, or radical 3 rather, sorry. So then you'll rationalize that. Remember, you can't have a radical in the denominator, and that's going to be radical 3 over 3. So there's my my point, radical 3 over 3. And I'm going to put that right here. Okay. So at pi over 6, I have a y value now. I want to go ahead and calculate those. We can go ahead. Let's go ahead and plot them out as we go. So we've got that value right there, 0, 0. And then in order to figure out exactly what square root of 3 divided by 3 is, I would have to go ahead and plug it into my calculator to figure that out. And that's 0.57. So we'll just say that's 1. We'll say that's 1/2. And really, whenever you're doing a rough sketch, you're not going to get exact. So you just do get as close as you can. So we're looking at a little bit more than 1/2. So I'm just going to guess it's right there. And I'll draw that point in. Okay. All right. So then we're going to go to our next value. And we're looking at y equals tangent of pi over 4. All right. And I'm looking at pi over 4 and remembering, well, pi over 4 is 45 degrees. So then I go over to my special triangle, 45 degrees, and I apply that rule opposite over adjacent. Opposite 45 is 1, and adjacent to 45 is also 1. So you have 1 divided by 1, so that equals 1. So you have the tangent of pi over 4 is at 1 now. Okay. And then let's see here. We'll go probably put a couple more in here. I can fit a couple more. So we'll do, and then I'll erase some sums. So we'll just keep them right here. So y equals, let's see, tangent of my next one. We're going to do, I can put that in there. 1, put it on our table. Pi over 3. And we're looking at pi over 3 and remembering, okay, pi over 3 is the 60 degrees. It's a radian measure for 60 degrees. So I'm looking at 60 and applying that rule, opposite over adjacent. So opposite 60 is radical 3, and adjacent to 60 is 1. So this is just radical 3. And I'll put that right here. Radical 3. And then try to fit one more down here. I don't know how well, hopefully somebody out there will see if you can see it good, and let me know how well you can see the board at the bottom. But we have one more I can fit in here. Tangent of pi over 2. And recall pi over 2 is 90 degrees. And that's why I put this up here. This is real general, just basic. Unit circle is it's hard to escape how it's so fundamental and so important. It's really hard to not use it. But pi over 2 is right here, 90 degrees. And if I apply that rule, I have y over x is going to give me 1 divided by 0. And that is undefined. And anytime you have 0 in your denominator, you're going to have a partition, an asymptote, vertical, more specifically, vertical asymptote. So we'll say undefined. And then see if I can get, well, I'll just put them in here. It's fine. I think it'll be fine. Tangent of 2 pi over 3. And if I did not remember what 2 pi over 3 was, I would use my radian conversion. And whatever you're going to, you put on top. So you put 180 over pi. Your pi's should always cancel out when you're going back from radians to degrees. 180 times 2 is 360. And then divided by 3, you see 36. Is that 120? Yeah. But I, in my brain, have to see it. So we have 120 degrees. And let's see, 120 minus 90 is 30. So that's your 30-degree reference angle. So you just subtract off the pi over 2 again. That's what I was doing. And it's giving me 30 degrees. That's just telling me what reference angle to use. Ooh, I better double check myself. 2 pi over 3, we have to use this. Hang on. Oh, you have to subtract it from pi. Hang on. You can't subtract it from 90. You have to, because whenever you're doing reference angles, it's from the x-axis, so you can't do, I'm giving you bad math. You have to take, and it's 180 minus 120. So it's 180 minus 120 is going to give you your reference angle, and it's 60 degrees. And if you mess that up, then you'll end up getting a wrong tangent value. So that's a good place, for me to almost make a mistake, because it's also a common place where someone else might. So it's just a particular, make sure that when you're calculating those angles, the reference angle is always from the x-axis. All right, so going back to my triangle, 60 degrees, and remembering that I'm in the second quadrant. So in quadrant 2, your x values are negative and your y values are positive. Okay, and that's another big deal whenever you're not using, like you're not looking at the unit circle, you might mess that up as well. But at 2 pi over 3, hang on. All right, I'm going to erase that because we know it's 60 degrees. And put this in here because I'm getting ahead of myself. All right, y equals tangent of 2 pi over 3. Okay, and that's going to be over here 60 degrees. We've got opposite 60 is radical 3. And adjacent is 1. And that's a positive, and that's a negative. How can I show you? Rather than just doing that, let me not be lazy, and I'll go ahead and pull up. I'm going to put it over here since I have room. So what you're doing is you're not using the unit circle, but you're still using your triangle in relation to the unit circle. So this is how we're doing it. So you have, let's see, you're in the second quadrant, and 2 pi over 3 is about right there. Okay, 2 pi over 3. And you're drawing a reference angle here of 60 degrees. So you've got radical 3, and then you've got -1, and then that's 2. So all you're doing is you're taking the Cartesian coordinate system, you're finding your reference angle in quadrant 2, and you're just drawing it out really quick. So you don't have to have the whole unit circle, you're just drawing that one triangle to get your value, if that makes any sense. So then when I do opposite over adjacent, I'm getting radical 3 over -1. So I just want to be clear how I'm getting that -1. All right. And so that's going to lead to a negative value. That's negative radical 3 for my graph right here. Negative radical 3. All right. This seems so much more easier, I guess, in my head when I was planning this. And I didn't practice today because I don't have time to do that. This is just me trying to spend time on my board and maybe possibly help somebody. All right. Anyway, let's go ahead and continue. All right. So we have 3 pi over 4, and that's the value we're going to calculate next. I want to see if I can try and fit it in here. So y equals tangent of 3 pi over 4. Okay. And 3 pi over 4, well, it's the bottom denominator is divisible by 4. And so not all those values are divisible by 4. So this has to be the 45, 45. So if you play around with these enough, then eventually you'll find that there's patterns in the numbers with these radian measures. And so I'm good enough to know that that is, so it's the 45-degree reference angle in quadrant 2. But if I didn't know that, then I would just do the old brute force method. I would say 3 pi over 4, I would subtract pi from it. So I say pi, and what I'm doing essentially is, because pi is out here, it's 180 degrees. I'm saying I'm at pi, and I need to back up 3 pi over 4. Or, yeah, and so that's what I'm doing. I'm backing up to figure out what the difference is between those two angles, if that makes any sense. All right, so I've got pi minus 3 pi over 4, and if I wanted to go ahead and stay in radians this time and not convert to degrees, then I could do that. I'm still getting a common denominator of 4. 1 times 4 is 4. So that's 4 pi minus 3 pi. And that's going to give me 4 minus 3 is 1. So we have 1 pi over 4, which is just pi over 4. So I was just wanting to show y'all me practicing because I like doing the math, but also trying to show y'all how I'm getting these values. So now I'm looking at a 45-degree reference angle in quadrant 2. So I'll just draw my triangle, and it's about right. And I have my little special triangle 1 to 1 radical 2. And remember that 1 is negative. So we have y equals tangent of 3 pi over 4 here. And that is going to equal our rule, opposite over adjacent. So I'm looking here, opposite is 1, adjacent is -1, and that's going to give me -1 for my value. So I'll put -1 here for 3 pi over 4. I've got 2 more values to calculate, so I'm almost there. Go ahead and erase this. All right, and 5 pi over 6 is, wait, 5 pi over 6, did I do that correctly? Oh yeah, 5 pi over 6 is going to be the 30-degree. Oh yeah, okay, sorry, it's right. 30-degree reference angle now. So we're going y equals, let's see, tangent of 5 pi over 6. And we're looking at our 30-degree reference angle, but we're in quadrant 2. So we'll just draw the triangle, or draw your coordinate system really quick, and then sketch your angle. You're about right there. And that's 30 degrees, so opposite 30 is the 1. Hang on, so that's 30. 60 would be radical 3. It's negative. And then your hypotenuse is always there off of the radius will always be your hypotenuse. And then your sine and your cosine are your components of your legs. So if this is 30 degrees here, then it's 1 negative radical 3. And so we're going to apply that rule. Opposite will be 1. Adjacent is going to be negative radical 3. Rationalize that. That's going to give you negative radical 3 over 3. And we figured that out. It was like negative 0.577, something like that. So we've got that one. Oh yeah, I forgot I was supposed to be drawing my points in there. I got a little ahead of myself. All right, power 6. All right, we got them all. So this is going to be negative radical 3 over 3. And then pi we're over here. So one more. Y equals tangent at pi is going to be opposite over adjacent. Let's see. So, or sine over cosine. So that's 0 over -1 so that's just going to be 0. All right, so that was fun. But we got all of our points, hopefully, and we'll get to see more accurate behavior of the tangent function. And then also, I would like to talk a little bit about the domain and range of tangent. It's not the same as sine and cosine, it's a little different. So we'll go ahead and see about doing this. I am starting to get a little tired. So I got to figure out what radical 3 is. The square root is between square root of 1 and square root of 4. So it's saying it's 1.73. So it's a little bit more than 1. It's almost a 2. So hang on, I'll make this a little bit bigger up here. We'll say that's 2. And it's not quite a 2. So let's see, radical 3. Let's see, right here. And then that's close enough. Oh, it looks like it's 2. Hang on, I'll put it back down a little bit. Oh, where's my eraser? We want it to be a little bit small. We can do a little bit better. All right, put it there. And then, so that's here. And then we have pi over 2 is undefined. So that's going to be my first partition, my vertical asymptote. Remember, it's not an actual line, so it's not going to show up in your graph. So we're just going to do it dotted. And then, let's see. Oh, I should have made it bigger. Oh, well. So what's happening with the tangent function? And then, okay, so we're going to 2 pi over 3 is negative radical 3. So we're all the way back down here. So yeah, I'm going to erase this. It's getting in my way. And we've got to go to 1, -1, and then a little bit further down. To 2, almost to -2. That's, yeah, it's just, it's a rough sketch. It's still not, I'm still not as happy with it as I want to be. So I think I'm going to scoot this point over just a little bit. Because it's only 15 degrees. Okay. Anyway. All right, so where was I? Over here, negative radical 3 is almost at -2 down here. So I have this point over here. And then I have -1. So at 3 pi over 4, I'm back up to -1. 5 pi over 6 was that point, that -0.57 or whatever it was. Here, I'll do it again. Radical 3. Okay, yeah, -5.7735. 2692. So I like to do all of the decimals that the calculator will give me. It's just a good habit to be in, because remember, whenever you divide your fraction, you get a decimal, and decimal is never exact. It's just approximate. So we've got negative 5.7. Let's see. That was the negative 5 pi over 6, or sorry, 5 pi over 6. 0.57 will be about right in there, maybe. And then at pi, it's back to 0. So it's, oh, yeah, do a little bit better. How's this doing? So it's kind of going off that direction. All right. And I feel like if I would have introduced the negative angles, then I would have been able to partition it a little bit better. But essentially, that's kind of what the tangent function is doing. It's doing some weird thing with these asymptotes. And so it's not, it seems like the graph yesterday looked better than that one. And I mean, it would be probably better if I could just show negative angles, but I really didn't want to talk too much about negative angles because, well, it's just another subject for another day, probably. That's not what it's doing, though. Okay, 2 pi over 3. Did I not? Maybe it's the way that I have these. Maybe I didn't mess up the order. So we've got pi over 2, 2 pi over 3, 3 pi over 4, and 5 pi over 6, and pi. So what it's supposed to be doing, I believe, is this number. So the values are just a little off. So it would have been here, here, and maybe here. Yeah, anyway, tangent's different. And again, if you have a graphing feature, that's nice, but if you're ever asked to sketch the graph, or you would need to sketch the graph by hand, this is how you would do it. And I somehow managed to take up almost the full hour explaining this one graph, or trying to. I really want to finish talking about the domain and range of tangent, and kind of explain a little bit more about the domain and range. So let's see, where I want to put that. So the domain of the tangent function is, it's all of the independent values. It's every value along the x-axis specifically. X is always going to be independent, and it's along the horizontal values, the x-axis, and it's always going to represent the domain every time. With tangent, With sine and cosine, I had no problem listing the domain using interval notation. However, with the domain of tangent, it's really, I mean, I'm trying to figure out how to represent it using interval notation, because as far as I know, you have to use it, you have to use set notation for domain, okay? Because of these asymptotes in the graph. So what you, in set notation, what you'll say is, you'll say it's the real numbers, okay? Because it exists everywhere except for here, this value. So it's the real numbers are, try that again, it's a scripted R. And it's a set of numbers called the reals, except for, so your minus, okay, and then you'll have a 2n plus 1 times pi divided by 2, and then you'll say such that n is an element of the integers, and then you'll have another scripted z, and then that's how you would represent the domain of this function. Because you have to exclude values of 2 pi that are, it's literally appearing every period of that graph, okay? So as long as n is an element of z, except for the partitions of 2 pi over 2. And then the range of the function, where it's existing as far as the y values, where is existing as far as your those vertical values, it's all the numbers, it's all reals. And so remember, from negative infinity to positive infinity, you're going to use a parentheses, because the parentheses, you're not including the value. You can't include infinity because it's expanding. All right, so I think that I covered, I think I'm satisfied with that. Yesterday, I just left the meeting and realized that I didn't really explain a lot about the domain and range or the period of the graph. So it's slightly different than the sine and cosine function, but I feel like that's a pretty good solid introduction to these three functions. And with that, I'm probably going to move on to a new topic. It's still trigonometry and it's still the trig functions. However, I'm going to start probably next talking about the inverse functions. So we have sine, cosine, and tangent. Then you also have your inverse functions. So I'll make, what I'm going to do is I'm going to live stream tomorrow at 6 p.m. And my goal is to try to discipline myself to live stream every day, Monday through Friday, 6 to 7 p.m. Central Time. And I'm hoping eventually that I will get some people that want to do math and want to see maybe need some help with their math. That would be really exciting. But in the meantime, I'm also getting more familiar with talking to the camera and just trying to teach to a camera rather than a room full of people. I prefer probably having real students, but this is better than nothing, I guess. I'll take what I can get. So I hope everybody has a safe and wonderful rest of their evening. And I will see you back here tomorrow. Thanks for watching.